Okay, so hey everybody, this is Mr. Bells again. This is Geo A coming to you. This is section 3-5 on slopes of parallel and perpendicular lines and equations of parallel and perpendicular lines. There's a lot of algebra to this stuff, and I'm going to go through it at a pretty good pace, so please just pause the video at any time if you're not sure about what's going on. Here we go. Let's give it a shot. So we're going to start with right here. We're going to start with this. Again, Geo A 3-5. Slopes of perpendicular and parallel lines. Well, first off, what are parallel lines? So parallel lines are lines that are coplanar in the same plane, but they're tilted so that their rise and their run is in the same ratio, whether or not that's all the way up there and all the way up there, whatever it is. So if this one rose 4 when it ran 3, this one's ratio would also be in that 4:3 ratio if they're parallel. So here we go. Parallel lines have the same slope. And we'll talk about with 2 points how to get slope in just a second. So what happens with perpendicular lines? So perpendicular lines like this, perpendicular lines, if this one's slope happens to be 3/5, which means it rises 3 when it runs 5, whatever units you want to put in there, 3 feet to 5 feet, or 3 inches to 5 inches, or 3 miles to 5 miles, then the one that's perpendicular to it has to have a slope of -5 to 3. So perpendicular, right, same slope was here. Perpendicular line slope is the opposite, and that means positive to negative, and reciprocal means to flip the fraction, right, from 3/5 to 5/3. So if the lines are perpendicular, their slopes are opposite reciprocals. So let's go ahead and talk about 2 points right now, and I'll go ahead for 6 and -2, -3. And if I had those 2 points and I want to plot them down just to get an idea of it, 4, 6, 1, 2, 3, 4, 2, 3, 4, 5, 6. There's a point, -2, 3, or -2, -3, 1, 2, 3. Then this line right here would have a certain slope, a certain rise and run to it. Okay? So how do I figure out that slope? Slope is y2 minus y1, or the change in the verticalness, right? Change in the verticalness, over x2 minus x1, the change in the horizontalness. So rise over run describes how it's tilted. So rises, 6 to -3 is 9, or 6 minus -3, 9. And then x is 4 minus -2. 4 minus -2 is 6. So it has a slope of 9/6, and we can always reduce that slope if we can, right? So fraction is reducible. So the slope of that line is 3/2, or 1.5. Okay? So if we wanted to have an equation of that line, remember an equation of the line has the slope and the y-intercept. Looks like this, y equals mx plus b. I simply take y equals, and I put the slope in there, and then I find out what the y-intercept is. So there are different ways you can do this, and if you read in the textbook, they'll show you a point slope formula too. I just like doing it this way. It's going to get you the right equation either way. I just like this one better. So now I have to do is this. If I'm trying to solve for b, I need to know an x and a y. Well, look, right over here, I have 2 of them, so I have an option. I don't care which one I use, but I will say this. I might be better off using positive ones. Okay, so I'm going to go ahead and put that in there. So 6 equals 1.5 times 4 plus b, and then move this up to here. 6 equals 6 plus b. Look at that. minus 6, minus 6, and my b equals 0, or my y-intercept, which is what b is, equals 0, which means that my line has to go through the origin. And look at that. My picture showed that it went through the origin. So one more time again, I'm going to do this. If I have 2 points, I can use the slope formula to find the slope. I can then plug the slope formula into y equals mx plus b, where the slope goes, the m. I then can pick either one of these 2 points. It won't not matter. And I plug them in. Just make sure the y goes into the y portion, and the x goes into the x portion. And then solve that equation for the y-intercept. And then simply write the equation afterwards. So my equation is 1.5x. And I don't have to put plus 0 on the end, but I'll put it tiny there so you know, plus 0. Because if the y-intercept was something, I'd really need to put it there. So there's my final equation on that one. So what happens if I'm trying to find an equation of a line like this? Let's say I had this line right here, and I had a point right there. Oop. That means class is going to start pretty soon. We're on a thing, setting that timer up. And I wanted to find an equation of this line right here that's parallel to this line going through this point. So I'm just going to make up a line. So let's go 4x minus 3y equals 12. And I have a point of negative 2, 6. Okay? So I'm trying to find an equation of a line that's parallel to this line and goes through this point. Well, this right here is a standard form equation, and the slope of that one is negative 4 over negative 3. So opposite of the a, opposite of the number in front of the x, over the b. So slope in standard form is negative a over b, just like that. So negative, that positive 4, and then just the b, which is negative 3. And we know that that's 4/3. So that means the slope of the line, this dashed line right here, must be 4/3 x. And I just don't know my y-intercept. I don't know what that is. I'm going to try and figure that out. Well, in order to do that, I have to have a point. So there's my point, negative 2, 6. And I'm going to plug it in here. 6 equals 4/3 times negative 2 plus b. 6 equals negative 8/3 plus b. 6 equals negative 2.6 repeating plus b. Add the 2.6 and my y-intercept equals 8.6 repeating. Okay? So what's my final equation of my line? Y equals, ready, 4/3 x plus 8.6 repeating. So I'm going to try and show this to you really quick on here on the calculator. I'm going to put in, this is my graphing calculator. I'm going to put in my original line, which was 4x minus 3y equals 12. And I'm going to have to tweak it a little bit on here to be able to show you how to do it. But trust me, it is right. Y equals, so I've got 4 divided by 3, x. And then the y-intercept is c over b. So 12 divided by negative 3 is negative 4, so minus 4. Okay, so zoom 6. That right there is my actual line. And you don't have to know how to do everything that I'm doing right now. That is totally okay. I'm going to go stat edit in my stats. I'm going to put negative 2, 6, negative 2, enter, and 6, enter. I'm going to turn my stat plots on. Again, you don't have to know how to do any of this stuff. I'm just trying to show you that there's my point right there. Do you see that? There's my point. And I'm trying to find the equation of this line through that point that's parallel to this one. And we said algebraically, we just found it right here, right? 4/3 x, y equals 4 divided by 3 x plus 8.666666666. And look at this. I found the one parallel to that line through that point algebraically. Sweet. So let me do another one for you right here. Now, what if I wanted to find, here's a line and here's a point, and I want to find the equation of this line, so it's perpendicular to that line. Okay, so I'm going to kind of put a little through there. So let's find an equation of this line, and I'm just making this up, right? So let's do y equals 3 halves x plus 7, and we're going to make the point 6 comma negative 2. I'm just making these up. I'm just picking some things. So I know that the slope is this, right? It's a lot easier to find the slope when it's in slope-intercept form. It's just that. So then what's the slope of the dashed line? Well, we talked right up here that the slopes of perpendicular lines are opposite reciprocals. So my slope of this line, slope being m, right, equals negative 2/3. So I write y equals negative 2/3 x plus b, and I just don't know what my y-intercept is. Okay, but I do know a point, so I'm going to go ahead and plug that point in, and I get negative 2 equals negative 2/3 times 6 plus b, and I get negative 2 equals negative 12/3 plus b, negative 2 equals negative 4 plus b, and I add 4 and I add 4, and I find out that my y-intercept actually equals positive 2. Is that good? So the equation of that line is y equals negative 2/3 x plus 2. And I'm going to do this pretty quickly for you here again. So on this, I'm going to put in my original equation again, which was 3 halves x plus 7. So 1.5 x plus 7. Good. I'm going to clear this one out. I'm going to go back to my stats, and I'm going to plot a point on my screen. My point was 6, negative 2. So 6 and enter negative 2. Again, you don't have to do this, just trying to show you stuff. So if I hit graph, so here's this line, and here's this random point way over here. So again, I'm trying to find this line right here, right? I'm trying to find an equation of that line right there. So the slope should be negative, right? Slope should be negative, and y-intercept should be someplace up around that thing. So, ooh, I'm feeling like this doesn't look very good. Let me do the math again. Let me double check. 6 and negative 2, 6, negative 2/3. Okay, we'll give it a shot and see if we did this right. So I got negative 2/3 x plus 2, negative 2/3 x plus 2 in graph. Oh, so it looks like it, right? And it's like, dang, it went through it, yay. But that doesn't look very perpendicular, right? I'm like, ooh, maybe I screwed that up. You know, that looks like an acute angle and that looks like an obtuse angle. So here's the deal. If you have a graphing calculator, your graphing calculator is wider, you can see the tick marks, right, than it is tall. So I have to hit the zoom 5 button, and that will give me a square window so that the intervals are consistent. And now you can see that it definitely looks perpendicular through that point. Okay, again, anytime, pause the video and you can go from there. Okay, so how about this one? Let's say that I'm trying to find the distance from a point to a line. And I'm going to go ahead and do that on that very last problem. So I want to find the distance from 6, negative 2, right, to the line y equals 3 halves x plus 7. Well, I know, right, 3 halves x plus 7. I'm going to do a quick sketch here for it. 3 halves x plus 7. 1, 2, 3, 4, 5, 6, 7, and 3 halves x. So it looks something like this. And this point, 6, negative 2, 1, 2, 3, 4, 5, 6, negative 2, is like right there. I know the distance has to be on a perpendicular, yes? Distance has to be on a perpendicular. So that means what I need to do is I need to find out that point right there. Well, that point happens to be the intersection of my two lines, y equals 3 halves x plus 7, and y equals negative 2/3 x plus 2. I already know this is 6, negative 2, right? I need to find the shortest distance to it, and that's on a perpendicular. So if I can find the intersection of those two lines, I can find that point. So watch, this is kind of cool on your graphing calculator. So I got these two things right here, right? And I'm going to go ahead and hit graph. And there's this cool buttons I can do. I can do second, trace, number 5, intersection, enter, enter, enter. And it tells me that that point is negative 2.3 and 3.5. And I'm going to say that's close enough right now for us, even though I'm rounding it. So negative 2.3 comma 3.5. And I look on my picture and I kind of go, yep, that looks about right on my picture. It might not be perfect, but it's about right. Okay? So then I'm going to do the distance formula from 6, negative 2 to negative 2.3 comma 3.5. So how far is it from negative 2.3 to 6? That's 8.3 squared. How far is it from negative 2 to 3.5? That's 5.5 squared. And I square root that whole thing. Again, that's just my distance formula. And on my calculator, just like this, 8.3 squared plus 5.5 squared. Enter, 99.14. Square root it, which is raising it to the 0.5. I get about 9.95, 9.96. So that distance is about 9.96. Okay. Right now for this course, if you don't have the graphing calculator and find the intersection, I'm totally okay with you using Desmos until we get in class and we can talk a little bit more about that algebra. Good deal? Okay, so I know that's a lot of stuff, a lot of algebra coming at you right there. Take the time, pause that video, work through it, practice it, do your sorry, we're on a timer here. Do your homework in the stuff, practice those problems, and you'll be good. And then ask me if you have questions. Okay? I'll talk to you later. It's Mr. Bells. See you.